Hi, and welcome to question 2 of the Leaving Cert Ordinary Level Paper 1 in 2024. So question 2 here is on complex numbers. Let's read through. The complex numbers Z1, Z2, and Z3 are shown on the Argand diagram below. One of these numbers is on the imaginary axis. Okay, so I see Z1 here, Z2, and Z3. They say in part 1, using the Argand diagram, write down the values of Z1, Z2, and Z3 in the form A plus BI, so the real part first and the imaginary part second. Okay, where A, B are elements of Z. Now, don't worry about that. That just means that A and B are positive or negative whole numbers. Okay, so it's not really all that important. If you know how to read complex numbers, that's irrelevant. So the first one, Z1, it's got a value of 4 on the real axis, okay? And on the imaginary axis, it's got a value of 3. Now we normally put the I there to represent that from the imaginary axis. So it's 4 plus 3I. Now Z2 is on the imaginary axis, so it's technically 0 on the real axis. You have to put the 0 in to satisfy this requirement. 0 plus 2 on the imaginary, 2I. And then Z3 is minus 2 on the real axis, minus 1I on the imaginary axis. And that's that. So nice handy part 1. Okay, I think I'm right there. Now part 2 says write down the value of Z2 in bars. Now Z2 means the distance of, which in complex numbers is generally referred to as the modulus. Okay, so if I quickly draw it, now Z2 was 0 plus 2I, so somewhere up here, write down the value of Z2. So, okay, that's actually really easy because it's the distance from the point to the origin, which, because this is 0 plus 2I, it's 2 units away. So the pilot diagram really helped me. Now I'm going to do it as if this is a normal modulus question. So a modulus, you can use the formula A plus BI, or the statement, to find out what A is, 0. B is the number in front of the I, which in this case is 2. Now the modulus formula is an adaptation of Pythagoras, A squared plus B squared. So the A value there is 0, plus the B value there is 2. Put that through the calculator. 0 squared is 0, plus 2 squared is 4. Square root of 4, value is 2. So either way, I got to the answer. Just seemed to be easier than you would have expected. Okay, so yeah, the little pilot diagram really would have helped there to appreciate what's happening. And that's all the modulus is using this formula, which again is Pythagoras' theorem. If this had formed a triangle, you could have used that triangle. Let's say I was finding the modulus of Z1. It forms a triangle. This is right angle, so the A and the B will be here, and he'd use Pythagoras to find C. Is in essence what we're doing. But this question was a little bit different than that because of where the point was. Now part B says you have a complex number here. V is equal to 15 divided by 1 plus 2i. Okay, write V in the form of A plus BI. So again, A and B are positive or negative whole numbers. So this is division of complex numbers. Now to divide complex numbers, we multiply top and bottom by the conjugate of the bottom. Now if I was to quickly draw 1 plus 2i, so 1 plus 2ab, somewhere like this. Its conjugate is the reflection in the real axis. So it'll drop straight down to the real axis and then on the same distance again. So it started here at 2, it'll be minus 2i here. So this one, the complex conjugate of this is 1 minus 2i. All you have to do is change the sign in front of the I. This is a quick way of always finding the complex conjugate. So I'm multiplying top by 1 minus 2i, and I'm multiplying bottom by 1 minus 2i. Now at the top, I could express this using brackets. 15, 1 minus 2i, all divided by 1 plus 2i by 1 minus 2i. And then just go left to right, top then bottom, and do the multiplication. So it's 15 times 1 is 15. 15 times minus 2i is minus 30i, all divided by, now on the bottom, I can do this the fast way, or I can go over here to rough work, 1 plus 2i multiplied by 1 minus 2i. Now the way I normally suggest is write one of the brackets out twice. I always say the second one. The first term can be written here, the first term of the first bracket. The second term of the first bracket can be written here. And then go left to right and multiply. 1 by 1 is 1. 1 by minus 2i is minus 2i. 2i by 1 is plus 2i. 2i by minus 2i is minus 4i squared. Now that's going to simplify down to 1 minus 4i squared. Now with complex numbers, and something they haven't said already, complex number is defined as I is equal to the square root of minus 1. That's what a complex number, like the root of the theory is. Now you can mess with anything, and I could square the I just to see what would happen. Now what would happen mathematically is if I square one side, I have to square everything on the far side. Now the square and the square root would cancel out, and you're left with I squared is equal to minus 1. So we can use that fact here, and instead of the I squared, I can replace that by minus 1. So I'll do that with the magic of an eraser. Now that gives me 1 minus 4 times minus 1 is 5. Now I was messing there before. Okay, so I'm dividing that by 5. Now 5 into 15 goes 3 times, minus 5 into 30 goes 6i. That's in the form a plus bi, and a and b are elements of z, which means they are positive or negative whole numbers, 3 or minus 6. That should be it. Okay, so that's the question down again. So again, once I recognize that this was division of complex numbers, and they don't actually say that to you, but if complex numbers comes up, they're most likely going to assess the modulus, which we saw already, and either of or all addition, subtraction, multiplication, division of complex numbers. So if you have those skills built up, you'll probably have a pretty good time. So if you recognize this is division of complex numbers, you have to remember this. This isn't given in the math tables. To divide complex numbers, you multiply top and bottom by the conjugate of the bottom. And that's where you have to remember the conjugate is just a matter of changing the sign in front of the I. So the conjugate of 1 plus 2i is 1 minus 2i. Now, or the conjugate of 1 minus 2i is 1 plus 1 plus 2i. And then you multiply top by the conjugate and bottom by the conjugate, and just do that. Okay, they're testing, are you able to multiply, add, subtract complex numbers? And you get down then to a point where you have to swap out the I squared is minus 1. It'll always happen. Now, when you're multiplying a conjugate by, or a complex number by its conjugate, the i's will always disappear. And that's why we end up with a 5. And then just recognize that 5 will go into 15 3 times. 5 will go into minus 30 minus 6 times. And you're good to go. So that should be the end of question 2. Oh, it's not. So let's read through part C. The complex number w is equal to 1 plus 2i is labeled here. So that's 1 plus 2i. Is shown on the Argand diagram below, not to scale. The three complex numbers a, b, and c are shown on the Argand diagram. One of these is the complex conjugate of w. Now we know that the conjugate of 1 plus 2i is 1 minus 2i. So where would that have to be? It would have to be directly below it. It says which of the complex numbers a, b, or c is the conjugate of w. Give a reason for your answer. So it's c. Okay. You could say it is directly below, or it is the reflection of W in the real axis. Now, excuse my bad writing. That's cool. This should do it. Okay, I said it just slightly a different way, but that's it. Okay, so that's a complex enough one in a way, but have a guess and try to give as good an answer as you can. For those who know it, it's easy. For those who don't, it's not. So that's the end of question 2. As always, if you want to copy the notes I'm working off, send me an email at shanetroy@gmail.com. Like and subscribe to get access to more playlists, and see you on question 3.